Hello students, this is Nitya Priya. Even today we are going to see the last memory management technique, which is overlaying. Overlaying in memory management is the thing that we are going to see now. And these are the contents of our concept. We are going to see about overlaying, then we are going to see overlaying in detail, then in which case overlaying should be adopted we see, then we see the advantages and the disadvantages, right? First thing is overlaying. What is overlaying? Overlaying is a process of transferring a block of a program code or data into the internal memory, replacing what is already stored. Okay, so let me explain this. When we need the memory, for example 50 KB memory we need, and we don't need the entire 50 KB all at once. For example, in our program there will be two processes. For instance, the first process needs only 30 KB and the next process needs only 20 KB. Okay, so both the processes will not go hand in hand. First we need to accomplish the process 1, then we just move on to process 2. So what we do, process 1 will run first, which requires 30 KB memory, and process 2 will run then the process 1, which needs only 20 KB memory. So when process 1 is running, we are in need of only 30 KB, right? So what we do is we require only 30 KB from memory, not the whole 50 KB, right? So after running process 1, we just step down to process 2. So at that time what we do is we just pull out process 1 from memory and we load process 2 on memory, right? So then we need only 20 KB. So totally we use 50 KB. So even though we use 50 KB, we don't use the 50 KB main memory data all at once. We first use 30 KB, then we pull down the process 1 out of memory. That is we just submit the 30 KB data into the memory. Okay, right? Then after completing process 1, we load process 2 on memory. So then we need only 20 KB, right? So this is called overlaying. The most important thing in overlaying is process 1 and process 2 should be disjoint. Okay, anyway, in any case, process 1 should not overlap process 2, right? So that is the main condition of overlaying. Hope you understand, right? So this is we see overlaying in detail. The concept of overlays is that whenever a process is running, it will not use the complete program at the same time. It will use some part of it. That's what I said. Okay, we run only process 1 once, then we move on to process 2. Both the process 1 and process 2 will not run at the same time. That's it. Okay, overlay concept says that whenever whatever part you require, you just load it at once. The part is done. When the part is getting done, you just unload it, then you pull it back, then you load the new part. Okay, so that is called as overlaying concept, when it can be adopted. So all the times overlaying cannot be adopted. So when it can be adopted, right? So that is what we are going to see here. Sometimes when the size of the biggest partition is it is less than the size of the program, then overlays can be adopted. I repeat, sometimes it happens that compared to the size of the biggest partition, the size of the program will be even more. In that case, overlays should be adopted. Okay, so the size of the program, usually in partition, we try to load the program in a single partition, right? So sometimes it happens that the size of the biggest partition is less than the size of the program. Okay, so we cannot go for even the biggest partition. So at that time overlays can be adopted. For example, if there are partitions like a partition with 50 KB and a partition like 30 KB and a partition like 20 KB. Okay, so we have three partitions in memory, for example 50, 30 and 20. What is the size of our program? It is 60 KB. So no one partition can accommodate my single process which is of 60 kb, because the size of this biggest partition is even 50 kb, which is less than the program. Okay, so at that time what can we do is adopting overlaying. That's it. Then advantages. It reduces memory requirement. Of course, instead of having 50 kb all at once, we use only 30 first, then we just give it back, then we have only 20 kb. Okay, we don't use the whole memory, so it reduces the memory requirement. The next one is it reduces the time requirement. Here we mean overlaying is generally done by users, not the OS. Okay, so when OS is doing that, it will suggest for some extra hardware or software. For example, in page memory management we use PMT, page map table. In segment memory management we use segment mapping. Okay, segment map is an extra hardware. So in that way, overlaying is not using any extra hardware, because OS is not doing that, only users are doing that. Okay, so that is another. In that way it reduces the time, right? And these are the disadvantages. Overlap must be specified by the programmer. As I said, it's done by the programmer. That's a disadvantage. So in that case, the user has to understand, yes, be very well versed about the OS things and the memory spaces, the partition size, everything he has to know. So that is one disadvantage. The programmer must know the memory requirement also. Then the overlap module must be completely disjoint. As I said before, when we load process 1, then after completing it, we unload process 1, then we just load process 2. In that case, what is expected? Process 1 and process 2 are completely disjoint. They have to be completely disjoint. Okay, if process 1 depends on process 2, no way we can unload process 1 and load process 2, right? So overlaying cannot be done there. So what is expected is overlapped module must be completely disjoint. Then the last one is the programming design of overlaying structure is complex and not possible in all the cases, right? So in some cases only we can adopt overlaying. And I hope you understood. Thanks for watching.